Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. Knowledge is power, now more than ever.
Hello, everybody. You're very welcome to a new episode of Redefining CyberSecurity here on the ITSPmagazine podcast network. This is Sean Martin, your host, where I get to talk all things operationalizing security in the business and broader society. And it's easy to get wrapped up in the cogs of business, because that's where a lot of money's made, and there's certainly a lot of attention paid to the consumer end of cybersecurity with a heavy focus on privacy. Of course, those two intersect. But as you'll hear today, there's a whole sector that I think doesn't quite get the attention it deserves, and that's our critical infrastructure. And there are many elements of that. There's water and power and waste, and certainly financial systems, health systems can be lumped into there, depending on what it is. Maybe manufacturing as well, and all kinds of stuff. Telco, maybe transportation, you name it. A lot of things that make us move and connect us all together and keep things running have systems too that tend to have vulnerabilities that can be exploited. And I'm going to talk a bit about that today and kind of the state of critical infrastructure and critical infrastructure security with Mr. Joe Weiss. Joe, thanks for being on the show.
Thank you for inviting me. And
I'm trying to think how I certainly came across control.com, I believe is the domain. Controlglobal.com, there we go. And it was one of your posts that caught my attention, that we're kind of missing the mark on critical infrastructure. And when we connected, you then sent another one. and clearly there's a lot going on. You mentioned before we started recording, there's even some more news today, perhaps, that makes today's conversation even more interesting. Before we get into all of that, Joe, a bit of your background, if you wouldn't mind, please give folks a sense of who they're hearing from today.
Okay, well, I'm a black sheep, if you will, in the cybersecurity world. I'm actually a nuclear engineer, and until 2000, everything I did was dealing with instrumentation, control systems, and equipment forensics. In other words, is the turbine working properly? Is the motor degrading, things like that. And in 2000 is when I helped start the control system cybersecurity program for the electric utilities. And it was a real shock, both for me going in there and for the industry having me come in, because I look at life as an engineer. That is cybersecurity going to hurt anything we're doing? Or conversely, can cyber, in a funny sense, help us? But I'm not worried about, if you will, a vulnerability here, there, or wherever. I'm worried about, has a motor been impacted? Has a valve been impacted? Has an electric transformer been impacted? So my life is looking at impacts, not vulnerabilities, and then trying to figure out what we do from there, and also how we can use it to improve reliability and safety.
I love it. And I think I'm generalizing here, because I know there are people that do take different, put on different glasses and look through things through different lenses. But it's easy to focus on what it does and what it's supposed to do and where it isn't doing that accurately. But then the other side of that equation is what you just described, which is, well, what's the impact of that, right? So if that motor is burnt out, or if that valve gets frozen or melted because it's overworked because of a compromise, that's the real problem, right? And so for me, it's interesting because you have the digital connecting to the kinetic, and presumably you have to have strong resilience in the mechanical end of things. with an understanding of resilience in the digital and how those two interplay, right?
And I'll add one other point, because you started with the digital connecting to the kinetic. In reality, what we really have is Mother Nature, which is analog, actually, connecting with kinetic. And in between Mother Nature and analog is where digital and, if you will, cyber come in. But what's been missing is really, that front end, which is, I use the term Mother Nature, but it's like the fact that something is heating up. That's Mother Nature, okay? And when something heats up, it has a physical impact. When it heats up, it's analog. What's happening is it has to get converted electronically. This is, again, where, cyber comes in, etc. Into, if you will, digital, and from there to Ethernet packets, which is really what puts it on to, where people start paying attention, because the network says things are going on. What's missing is the very front end. Should something be heating up? Is it truly heating up? And why is it heating up? And that's the part you don't see in the normal world of cybersecurity. And that's also where sophisticated attackers will come in, because you can't see it.
And I'm curious, and this might be a slight tangent, but do we have visibility into that information? Are there sensors on these things where we can see that Mother Nature view?
Yes.
Yeah.
Now, is it common to use it? Because there are two things.
Okay.
Number one, we have sensors there. In other words, we're looking constantly in the engineering world, not in the cyber world, in the engineering world. We're looking at pressure and temperature and flow and voltage and current and position. I mean, you think about in an office where you have all of these, sensors monitoring movement in order to turn lights on or off in an office. There's all of this stuff. It's called the invisible visible. It's there all over. You just don't pay any attention to it because it's just part of the background. These sensors are not something you pay attention to.
Right.
The cyber world normally doesn't pay any attention to anything that doesn't look like it has a keyboard or a cell phone type of thing.
Right. Can you paint a picture for me and for our audience of? I know there's probably no typical example, but I don't know. Pick some critical infrastructure. It could be power generating station. It could be power storage. I don't know. Pick something. Water treatment. Mm-hmm. Pick something there and kind of describe what kinds of systems exist there and how many sensors there might be. Can you paint a picture there so we can kind of grasp what we're?
Yeah, if you're talking about, say, a large power plant or, say, a refinery, they can have on the order of 25 to 35 or 40,000 sensors. And what they're doing is in real time measuring, like I say, pressures and levels and flows and temperatures and valve position or, like I say, voltage or current. All the physical state of the world is being measured in real time. So this is, like I say, microseconds to milliseconds. All of this is being measured. It's being sent electronically off to controllers. The controllers have been pre-programmed to basically say, I want to keep this tank of water at 80 degrees. So I'm monitoring the temperatures and pressures and pump speeds and everything else, all to make sure that I keep that tank of water at 80 degrees. If my sensors start telling me, hey, I'm now at 85 degrees, then the controllers are going to automatically, based on the sensors, say reduce pump speed or reduce a heater or whatever to bring the temperature back from 85 to 80. The flip side is if I'm at 75 degrees, I'm going to say increase pump speed or increase a heater or whatever, because I want to be at 80. Well, I'm doing that constantly in real time. The other point I think that's important is the operator who's monitoring this, who's sitting in front of generally a bunch of Windows screens, is going to see what's happening, but seconds to minutes later, he's not seeing what's happening instantaneously. So what's different is the operator really is not controlling keeping that tank of water at 80 degrees. These control systems are automatically doing that and feeding that information back to the operator. So if anything happens with those sensors or those controllers, those actions are going to occur, right or wrong. That's why you worry about cyber, right or wrong, before that operator ever sees it or has a chance to correct it. And what's happening today is the focus of cybersecurity is not on those sensors and the controllers that are trying to keep this tank of water at 80 degrees. The focus of cybersecurity is on those Windows screens that the operator is looking at that are, seconds to minutes old and may or may not even be providing accurate information. And so much of what the cybersecurity world is pushing is not, if you will, coincident with what you're trying to actually do in the physics world. That's a really big part of our problem. And I want to take it a step further. This problem starts in our education institutions. And that is, if you're going into cybersecurity, that's in computer science. Very, very few universities require that if you're in computer science, that you have to take any engineering courses, even a basic introduction to engineering. So the people coming out of universities into the cybersecurity world are, I hate to use the term, clueless about engineering. The flip side is those people in the engineering disciplines, whether it's electrical or mechanical or chemical or nuclear or systems, aerospace, name it. Again, this is never say never, never say always. But by far and away, the vast majority of universities do not require anybody in an engineering discipline to take an introductory course in cybersecurity. So here we have these two worlds, each trying to do something different. And in reality, what they're both trying to do is almost mutually exclusive. The cybersecurity world wants to lock everything down strictly on a need to know and, essentially shut down if you feel that there's been a compromise somewhere. The engineering world is all about safety, reliability, productivity. And to do that, you really want open interoperable systems, which is kind of a no-no for cyber. They want, you've got engineering experts who don't feel cyber applies to them. You have the cyber world who feels everything is about the bits and bytes, and the fact that a motor is heating up has nothing to do with what they're doing. And this situation is not getting better, it's getting much worse.
I want to talk a bit about that, because before we started recording, you mentioned, you had me reminiscing about visiting the big yellow campus there in Northern California where I used to work. And you told me a story about traveling around to different entities to talk about this.
Yeah, well, when I started or helped start anyways, the Control System Cybersecurity Program, this is in 2000. Okay, I was at the Electric Power Research Institute. I was the technical manager of the program. And EPRI's in Palo Alto, Symantec, Trend Micro, HP, I keep on going. All of the old names are here in Silicon Valley. So I didn't have to get on an airplane. What I did is I basically got on a car, or I walked down the hill, for example, going to PARC, Palo Alto Research Center. I'm going to all of these big names in the world of cyber, going, with industrial strength knee pads so I can beg and plead, would you please work with us on cybersecurity of these infrastructures? And each and every one said, well, let's see, are you using Windows, or are you using, all of this standard IT stuff? And their interest was in protecting servers, because that's their life. That's, like I said, what you did at Symantec. You start talking about a pump, a valve, a sensor, an actuator, and I had to bring pictures and spell out, that's what this stuff is. This is not, neither side was talking to the other. The ultimate irony is that in every one of their buildings, in every building, you have sensors measuring temperature and pressure and flows and humidity and
security operations centers and labs with
and
power
everywhere.
backups and generators.
All of that.
Cooling
And so
systems.
the ultimate irony is that the cybersecurity world is worried about the bits and bytes of data. The engineering world is worried about the physics and the process. And they don't talk to each other. So here you have all of these engineers or facility people worried about keeping the data center at the right temperatures, and have, the right cooling and everything else. But the whole focus of a data center is the servers and the data. Yet we've had many, in fact, between August 30th and October 14th, there have been 3 major data centers worldwide shut down because of control system cyber issues. And none of them were actually identified as being cyber related. They were all called mechanical failures, which also meant there was no cyber incident response initiated, anything. Yet these issues took those data centers down for hours. And in one case in Singapore, it took out Deutsche Bank and Citibank's operations for something like, I think it was 4 hours or so.
Wow. So these are private entities, commercial entities supporting data centers that support other businesses, and you mentioned financial.
Yeah, or keeping air conditioning going, or keeping power going, or keeping water going is something not only needed for private It's needed for every government operation. This is what keeps our, way of life going.
So what, we could probably pick apart all the places where, in the traditional IT world, the core conversation is around connecting security to the business.
Yes.
And there's a huge gap there. What I'm hearing here is connecting security to the operations.
Yes.
Connecting security to safety, basically. And so how do you see a path forward? You mentioned education earlier. I think that's probably one area, but where do you see we need to make some changes?
I'm going to give you an example of something that's actually happened. We actually wrote it up. It's in the November 2022 issue of IEEE Computer Magazine. So what I'm telling you about is a real project with real results and why it worked. In other words, why we were able to do this. And the flip side, which is where everybody else is, shows you this gap of where we are versus where we should be. This was a $1 billion manufacturing facility. And the Windows displays said everything was working normally. But the plant people felt they were very uncomfortable. Everything seemed to be working properly, but the gut feeling thing that this doesn't feel right. So they did a project, and they basically took one of the manufacturing lines in this, like I say, $1 billion facility. And this manufacturing line had 16 sensors. They were measuring pressure, temperature, flow, motor amperage. In other words, if you will, the current in the motors, is it going up, down, whatever, valve position, and vibration. Now, that's typical of every single facility in the world of any type. And what was done here, which is what was different, is there's a couple of types of technologies. I'm not going to name any names, but I'm going to just talk about the type of technology. This particular one that was picked was looking at the raw physics of the sensor reading. So what they were looking at, and I'm going to sound propeller head techie for a minute, they were looking at the 4 to 20 milliamp current readings. So they weren't looking at pressures or temperatures or flows. They were looking at the physical response of the sensor. And then, again, this is a year ago, February, so this predates ChatGPT. But they were using machine learning to take those values, those physics values, and try to understand, really, was the real ground truth measurements, were they the same as what you were seeing on the Windows displays in the control room? Because if they were, then, hey, people with your, queasy feelings, suck it up. It's real. What we've found, and this is part of the reason this is written up in this IEEE Computer Magazine article, more than half of those sensors were either inoperable or out of calibration, meaning they were not accurate. Only the Windows displays didn't see any of that. Major, oh my God, what is this? Okay. The next thing that was done is they were looking at the main pumps, what are called main feed pumps, which are, feeding the process. And when they looked at the operator displays, everything seemed normal. When they started looking at the raw physics of the signals, what they found was the pumps were having real problems, but it was occurring in seconds to less than a minute. It was too fast for Windows to see it. Windows had no idea. There wasn't a problem with Windows. Windows was never meant to be an engineering tool. Well, the next thing that was done was doing extrapolating what was found in that one line and extrapolating it to the facility. And then doing a very, very, very detailed cost impact analysis of what we were finding. And what we found was this billion-dollar facility was taking a 3% hit on net productivity because the sensors and the systems weren't working as they should. Now, again, the reason this is in IEEE is a couple reasons. Number one, here's real dollars associated. Number two, the sensors are the input to every network cybersecurity monitoring program. So it's basically saying, guess what? All of your cybersecurity monitoring is based on untrusted or wrong data. The other thing, and that's where I was coming from too, because this program was called a productivity program, corporate was involved, engineering, plant management was involved, all of engineering was involved, and cybersecurity was involved. If this would have been called the cybersecurity program, one of them would have been involved.
Yeah, interesting.
So again, this is why this is in the, like I say, IEEE Computer Magazine. Again, for what it's worth, just deviating for a minute, we have an article that's supposed to be in the December issue, like this month's issue of IEEE Computer, and it's about the data centers and their shutdowns. So what we're looking at is this gap that is, and by the way, none of this has to be malicious. As an engineer, I don't care whether, quote unquote, it's unintentional that you're losing 3% in net productivity, or because somebody is hacking you to lose that 3%. Because at my level, it doesn't matter.
Yep.
And I want to take it one step further. And this is part of the problem. Again, I'm going to make a general statement. In the cybersecurity world, to cybersecurity people, if you can't tell them it's malicious, they simply don't care. What Stuxnet, if you remember what Stuxnet was, for those who don't, that's, attacking the centrifuges in Iran. What they did is they made a cyber attack look like an equipment malfunction. Because of that, it was literally more than a year that those centrifuges were being damaged or destroyed until that PC was sent to Belarus and they found this, some software issues in it. Nobody ever thought to say, hey, is this misoperation of the centrifuges cyber? It was just assumed to be systemic malfunctions, design malfunctions. And by the way, that is what is going on. Where Iran is going, where China is going, where Russia is going. If you want to cause damage, you go that direction because nobody's going to see it. The engineers are going to see it as a problem. The cyber people are going to not see it because there's no anomaly on my network.
So in the example you gave, the first IEEE, the November edition, it It wasn't until they did a side view of it did
Yes.
they spot the 3%. So presumably there were networking issues, scalability issues, and the overall system that just weren't, those anomalies weren't flagged.
Correct.
Clearly, when things in the other example, the second IEEE that you're putting out, well, I don't know if it's that, but the other case you just gave where things actually started to fail, that's easier to spot.
It is by the engineers.
Right. So that's where I was going with this. So let's assume for a moment, we'll go back to we can't spot it yet in a minute, but let's assume for a moment we see something. How do we get to a point where, and does it matter? Because,
well, by the way,
how do we bring the teams together to actually figure out what's going on?
These are phenomenal questions.
Yeah.
What you're asking is what we've been asking for the almost past 25 years. When we first started the UPRI program, we thought of this term called donut diplomacy, which was, have the engineers go have coffee and donuts with the IT or vice versa. And one would think that would have been all that mattered. Wrong. That's why we're still in this position we're in today. Okay.
Where's the breakdown then?
One of the things that's missing is a psychologist in all of this to say, why in the world are these two worlds not willing to accept each other? Now, I'll give you one other too. Cyber lives with network or security operations centers. It is monitoring in real time all of the internet protocol networks. Well, again, where the if you will, engineering or control system world starts is with serial or point-to-point networks that eventually become, your internet protocol networks. Only that's not looked at, and you can't find that in a network operations center. Meanwhile, in the engineering world, you have a control room or a control center, and you'll see just screens everywhere. And what they're looking at are, pressures, level flows, temperatures, voltage and current flows. It's an engineering center. Quite often, these two centers may be separated by miles, states, or countries. And I'm not being facetious when I say they could be separated by countries. So what's happening...
And by operating system, and by network, and by
everything, okay? So what's happened is when in a control room, you start to see a pump, starting to heat up, or I should say a motor starting to heat up, or you start to see a decrease in amperage or something. In other words, a physical issue that you start seeing in the control room. The network operating center is generally blind to that because that's not affecting any bits or bytes. Meanwhile, where you're in the network control center, and you start to see bits and bytes starting to go on, how many times does somebody there call up somebody in a control center saying, hey, are you having any problems today? That almost, I'll rephrase it, that rarely happens. And so these two worlds, and that's what they are, you can almost say these two universes are operating in parallel and oftentimes divergently, because I remember I had to give a presentation here in the Bay Area a number of years ago. And a utility person showed up because they were told they needed to hear what I was saying. And we ended up going to lunch afterwards. And this is the cybersecurity lead. And I asked him, And remember, this is for an electric utility. And the question is, if there were a cyber issue, and the only way we could keep the lights on was to open up the firewall, would you open up the firewall? You know what the answer was? No. He'd rather have lights go out because that's what he was measured on, than to have his firewall open. One of the issues we have, the engineers have no KPIs and no metrics or anything in terms of cybersecurity. The network people have no metrics for the fact that if you're an electric utility, your operating reliability is being affected.
So let me ask you this, Joe, because you nerd out on sensor technology. you went had a little bit of fun there. I nerd out on risk management, and I'm just wondering. To me, there has to be an entity above IT and OT, ICS, CI worlds that look at risk. Because to your example of the security lead and electrical organization, they're measured on protecting the infrastructure, even at the cost of service delivery. That doesn't seem right. I don't know that he would have the ability to make that decision and have it stick, which is kind of my point. There has to be somebody that oversees the whole kit and caboodle that says, here are our objectives, here's the risk, here's what we're willing to tolerate, here are the decisions that follow because of that. Does that not exist?
Not well. And this is one of the things I've been pushing with insurance companies and credit rating agencies. And take it back for a minute. Risk is frequency times consequence. In the control system world, there's only two numbers we don't know: frequency and consequence. Okay. Now, the other point is when it comes to cyber, who's responsible? The CISO. Here's the issue. The CISO has no responsibility or ownership of a single piece of equipment. The CISO doesn't own the turbine, the transformer, the relays, the pumps, anything. Meanwhile, the person who does own all of that is kept out of the loop because he or she is not a cyber person. So when those discussions occur with the risk manager and the C-suite and the board, who's in there? The cyber people. The system is broken. And that's what you're seeing, in a sense, play out today, like with the Unitronics issue. The people that understand the engineering piece are not involved. The people who understand the network piece are the ones making all of these decisions. And in the Unitronics case, this is a control system. It is not a router, a switch, a firewall, or anything else. But the decisions being made are made as if that controller was the same as a firewall or a switch, and it's not. And so, without trying to go into any more detail, the guidance that is coming out is simply inappropriate.
Yeah, needs a boost in some areas, for sure. Needs a boost. So funny enough, that was the driver for this conversation, but you and I agreed to kind of broaden the conversation out a bit, which I'm very grateful for, and I think a lot of people listening will be as well. But I'm going to link to the original article and the subsequent one that you shared with me on the Unitronics piece, so people can look at that and dig into more detail there. I'd like to, Joe. I'm like impressed, curious. I don't know what the right word is. Control Global. You write a ton of stuff there. Can you give me an overview? I mean, let me just go there quickly, because if you click on the drop down, there's measure, control, manipulate, visualize, network, manage, protect. All these categories have 6 to 10 items underneath them, and you contribute to some, many, a lot. I don't know. Yeah. Can you give me an overview of what's going on there? Because I'm fascinated. That's the word I'm looking for. Fascinated by what you're doing.
So let me
and the work you're writing about, which is very good.
Let me explain also one other thing. I wear 2 hats. One is my daily work hat. I'm an independent consultant. My company is Applied Control Solutions. I have a pro bono hat where I'm the managing director of the International Standards on Control System Cyber. Because I'm a huge company of one, being able to maintain, a blog site of this consequence is a difficult thing. So Control Magazine has allowed me to use their site to blog. So Control Global is simply my blog site. And unfortunately, by the way, that's got me into trouble, because there are a number of other magazines and others who feel that I work for them for Control, and I don't. I'm an independent consultant. They just happen to give me that spot and maintain that website for me. So I just wanted to clarify.
No, I'm glad you did.
What that is this is arguably one of the only places you'll find which is the engineer's view of cybersecurity.
Yep.
And that's what makes it so different, is because these worlds are still not working together because their goals are different. And in a lot of instances, they're mutually exclusive. And we have to break that. And so far, it's not happening.
Yeah. Well, Joe, this has been fantastic. And yeah, that what you just described, the engineer's view of cybersecurity, is what caught my attention. You articulated it better than I was thinking it. And you're very prolific there. And I was cruising through some of your articles, very detailed, and certainly it's clear you've been doing this for a few days. You have a bit of knowledge there and experience of what's going on, and I appreciate what you're doing. And I want to thank you for joining me today. And who knows, maybe you'll be back in a few months or something. We can talk about some important updates. Hopefully, there's something interesting and a positive note to talk about in the new year. So thank you, Joe.
Sean, thank you for the invite, and hope to do it again later.
Absolutely. And for everybody listening, I'll link to the 2 articles I mentioned. Perhaps Joe can share with us the IEEE links, the one that's coming, or one that exists and one that's coming. I'll add it to it. And appreciate you all listening and watching. Please share with your friends and enemies, and subscribe, and enjoy, and most importantly, think. Thanks, everybody. Thanks, Joe.
Thank you very much.
We hope you enjoyed this conversation. If you learned something new and this story made you think, then share ITSP Magazine with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our columns. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.